Hi guys, greetings of the day. Welcome to my YouTube channel for learning a subject called Fluid Power Systems for 7th semester and Fluid Power Engineering for 5th semester as per video syllabus. If you haven't subscribed to my channel yet, kindly subscribe. Also click on bell icon to receive the latest lectures as and when it is uploaded in my YouTube channel. Now let's start the session number 43, which is based on the following topics. Now we will discuss the spool walls, flow control walls and the shuttle walls one by one and followed by other type of walls also. First we'll discuss about the spool walls. Spool walls are more preferred because they offer extreme flexibility in interconnection through a simple sliding mechanism. They are also relatively simple and economic to manufacture. But the drawback is adequate sealing has to be obtained by fine surface finish on both the spool of the cylindrical boring. With closer tolerance to ensure minimum clearance to prevent internal leakage. In practice, spool walls are usually lapped to fit. The two basic elements of spool walls are a cylindrical bore in a housing and a plunger, that is nothing but the land which you can see in the figure. The plunger provides the sliding seal with the axial movement covering and uncovering the ports, thus connecting and disconnecting the interconnection ports. Port blocking is provided by latch on the spool with intervening waste sections, ports, connections between the ports to the bore. This makes it easier to provide multi-way and multi-position switching. The main problem associated with this type of valve in certain applications and particularly with the larger spools, the precision bore and fit may be distorted by externally applied loads. Problem of maintaining close tolerance may be simplified in case of pneumatic spool valves by providing spool grands with seals such as boring located in groove, but the disadvantage is as the sealing rings when the slide over parts are subjected to cutting action and distortion is going to take place. Coming to flow control valves, the flow control valves are essentially throttling devices. Their geometry varying from that of a fixed orifice to adjustable needle valves or shaped grooves capable of providing progressive throttling. The symbol of fixed and variable throttle flow valves as shown in this figure. Their basic action may be combined with a second function such as non-return. Then coming to one more type of valve which is called as a shuttle valve. The shuttle valve is an automatic type of direction control valve with three ways and two position characteristics. This is based on the three-port body with a moving valving element in the form of a spool or shuttle or a ball. A shuttle valve is also known as double check valve. It is primarily a pneumatic device and is rarely found in hydraulic circuits. A shuttle valve allows either of two pressurized inlets, whichever is greater from two sources. The higher pressure inlet moves the shuttle to a position where it blocks the other inlet. It is thus more of a special type of valve rather than a true directional control valve and is basically used for logic gate that is called as OR switching. Construction is very simple and consists of a spool inside a cylinder which you can observe in the figure A and B is going to be its graphic symbolic representation. If the pressure of air at A is higher than the pressure at B, then the ball is blown towards B and the port B is blocking the connecting the ports A and C. Similarly, when the pressure B is higher than at the end A, the ball is blown towards the A and the port A is blocked, connecting the ports B and C. And the figure C shows the typical application where single acting spring retracting pneumatic cylinder is extended from either of two manual stations. Isolation between the two stations is provided by the shuttle valve. Now let us understand the next type of valve is called as quick exhaust valve. Quick exhaust valve, also referred as a fast exhaust valve, is a shuttle valve with a valving element in the form of a shuttlecock. Hence, its graphical symbol is that of a shuttle valve. A quick exhaust valve is used to vent cylinders quickly. It is primarily used with a single acting spring ridden pneumatic cylinders. This in fact increases the speed of the cylinder. It consists of a movable valving element in the form of a cock shuttling between the inlet and outlet ports, connecting the inlet port to the system port and the system port to the exhaust port. And the figure A shows the constructional feature and figure B shows the graphic symbol of a quick acting exhaust valve. It consists of ports P, A and R in a body and the valving element in the form of a shuttlecock shuttles between P and R, connecting the ports P and A and R. When P is connected to high pressure, the shuttle blocks the port R, connecting the ports P and A. High pressure air extends the cylinder. When the direction control valve is deactivated, the port P is blocked by shuttle and exhaust air flows to R through A. Fast exhaust valves are usually mounted to local or onto a cylinders and speed up response by avoiding any delay from the return pipes and control valves. This can also be used as simple control valves. Then coming to another type of valves that is called as we are going to discuss are pneumatic time delay valves as well as twin pressure valves. We'll discuss first the pneumatic valves. And pneumatic time delay valves are used to delay operations where time-based sequences are required. And figure A here shows the construction of a typical valve. This is similar in construction to a 3 by 2 way pilot operated valve, but the space above the main valve is comparatively large and pilot air is only allowed in via a flow reducing needle valve. There is thus time delay between the application of pilot pressure to port Z and the valve operation as shown by the timing diagram which you can observe from figure B. The time delay is adjusted by the needle valve setting. The built-in check valves causes the reservoir space above the valve to vent quickly when the pressure at Z is removed to give no delay off. The wall shown in this figure is normally a closed delay on the wall. Many other time delays walls can also be obtained. All of these use a basic principle of the air reservoir and the needle wall. Now let us understand more clearly about twin pressure valve also. The twin pressure valve is also called as pneumatic AND gate. Here, an output is produced if both input signals are fed. This valve has three ports A, B, and C. Two ports A and B for input signals, and the port C is for output port. When the signal is fed through port A, the spool moves to the right and blocks the passage from A to C. Similarly, when the signal is fed through B, the spool moves through left and blocks the passage from B to C. If signal is fed simultaneously through A and B, then the spool remains in neutral position and the air will pass through C from both A and B. And the figure A shows the three distinct positions of the valve and the figure B shows its applicational circuits which is applied. By this, I can conclude that this fourth module has been completed and these are the few assignment questions for which you can answer. And if you could able to answer for all these questions based on the videos what you have followed, you can able to clear the examinations. And thanks for your patience listening to the session. If you have any sort of doubts, feel free to use the comment section for further discussion. I will answer all your questions related to the topics covered in this session. Don't forget to like, share and subscribe. Have a great day. Signing off, Vijay Tavantan.